Hello, this is Dr. Jeremy St. John. Today I'm looking at the Electro-Poly example. This is Cliff Ragsdale's Spreadsheet Modeling and Decision Analysis, the 7th edition, and it's on page 66 to 70, and I'm on page 66 right now. I went through the case and I've just pulled out the most important aspects that as far as for modeling this problem. So Electro-Poly, they got a contract for $750,000 to provide slip rings, and these slip rings they're for the manufacturing of tank turrets, aircraft turrets, gun turrets. I don't know what it is. It doesn't matter. Their contract is for 3,000 of their Model 1s, 2,000 of their Model 2s, 900 of their Model 3s. The problem is they can't do it. They can't do it all. They need to outsource some of the work. And it tells you here on page 67 what the problem is. They have a limited amount of hours available for wiring and for harnessing each of these units. And each unit takes a different amount of harnessing time, hours required of harnessing time, and they have this a certain amount available, and each one takes a different amount of harnessing time, and they have a different amount available. That will be important when we build our constraints. So for this case, we have three different models. At first glance, it looks like this is just three instead of the two that in the earlier example of the hot tubs, but actually each of these models has two different costs associated with it. And this is obviously a minimized cost problem. They're going to get $750,000 whether they do it efficiently or if it costs them $1,000 to make it or $1 million. It doesn't matter. They're going to get $750,000. So they're getting $750,000. The goal here is to minimize the cost. So they have a different cost associated with Model 1, make it in-house, and Model 1, buy it. Buy it just means let's have the factory down the street make it. So the factory down the street, they're sure, we'll give you, it's wholesale price, but they need to charge a little bit. So they'll make it for us for $61, or we can make it ourselves for less, for $50. Model 2, we can make it for $83. They're going to charge us $97. And Model 3, we can do it for $130 in-house, or they can do it for $145. And you'd think, hey, look, let's just look at which one has the least markup, and let's just have them make those for us. But the problem isn't as simple as that, because we have each of these models takes a different amount of wiring hours and harnessing hours, and so one of them might be cheaper to have them do it, or not much more expensive, but it could eat up a lot of our hours if we make the higher one. So we're not sure which one. We're going to give this problem to Solver and let Solver make the decision. So let's look on. The point is here that I have 6 decision variables, and I want to set this up just like a standard problem, but with 6 decision variables.